Hello everyone. Today we will talk about assignment 11, week 11 previous year question paper and their answers. So for the course classical mechanics of a single particle. Okay. So my name is Papia and I am the Payment NPTEL teaching assistant and the course instructor Professor Supratik Banerjee. Okay, so coming to the first question. So basically, in this week, in the week 11, assignment 11, what sir taught in this whole week? Sir was taught basically about the phase space and the properties of the phase space. Then there was something like fixed point and what are the fixed point, what are the different types of fixed points, and there were some examples of fixed point he was discussed in his lectures. And after that he told about that how we can come up with the classical mechanics of a single particle, example of fixed points, and what are the properties of these fixed points. So he has showed us two examples of the classical mechanics. One is x double dot plus x equals to 0, which is like simple harmonic oscillator problem, and another one was like that x double dot minus x equals to 0, which will give the hyperbola like phase space and all. So here in this week basically the questions which will come that will be exactly cover all the phase space related questions, and it was already also mentioned, included the previous year assignment questions as well. So let's start. Basically the first question is, a particle is moving in a straight line in three-dimensional space. What is the dimension of its phase space? So as sir has already explained about this dimension of the phase space. Okay, so I just want to mention here dimension of phase space is like 2 into degrees of freedom. Okay, why it is like that? Actually degrees of freedom, it is nothing but the number of generalized coordinates, right? This I have already mentioned in the last class as well. So this is the degrees of freedom is the number of generalized coordinates, and why the dimension of phase space is 2 into degrees of freedom? Because the phase space basically consists this type of thing, qi and qi dot. So now you can see that qi is the generalized coordinates. Okay. So as qi is the generalized coordinate and qi dot, these two is going to consist of phase space. So that means if I am having let's say n number of generalized coordinates, then I will have 2n number of phase space. Like the 2n number of phase space means the dimension of the phase space will be 2n. So now for any system where we just want to know the dimension of phase space, for this case only we need to know the number of generalized coordinates, and we just need to multiply that one with 2. That will give me the dimension of phase space. Now coming to the question, what that sir was asking in the first question. The particle is moving in a straight line in three-dimensional space. Okay. So for this case, I can see that one particle can move on the straight line in 3D. So from the layman language, it is showing that it might be possible to have the generalized coordinate as 3 because it is in 3D space. But actually it will be only 1. Why? Because this is the particle is moving on the straight line itself only. And for straight line case, we just need one generalized coordinate to explain the motion, to explain the position of the particle. So for the particle moving on the straight line has DOF which is 1, or you can say that generalized coordinate is 1. So obviously, let's say I am talking about generalized coordinate as Q. So we can say that the dimension of phase space will be 2 into 1, which is 2. And what it will be this P and P and Q and P, or I can write as Q and Q dot. Sorry, I did not mention that one. I wanted to write here. These are this. So now we can see that 2D phase space. So the question answer will be 2. So for that, what we have done, we just calculated the number of degrees of freedom for this system, and number of degrees of freedom means how many generalized coordinates are present in this system, and then we just multiplied that one by 2 because each generalized coordinate corresponds, one generalized momentum. So that means for the phase space, generalized momentum and generalized coordinate both will be there. So as a whole, there will be a 2 into degrees of freedom number of dimension in that phase space. So for this case, we calculated that the number of degrees of freedom was 1. So the dimension of phase space is 2. Okay. Now coming to the second question. The dimension of phase space for a particle constrained to move on the surface of a sphere. That is exactly similar to the previous question where we just need to calculate the number of degrees of freedom for this system. So the system is what? A particle constrained to move on the surface of a sphere. Okay. For this case, first of all, sphere means we need to go for the spherical coordinates. Which are r, theta, phi. So this will be r, but the particle is constrained to move on the surface. That means always it should move on this surface of the sphere. So which means that r will be constant here. That means here the generalized coordinates for this system is only 2, which are theta and phi, right? So if the generalized coordinates are 2, that means theta and phi. So the dimension of phase space for the particle moves on the surface of the sphere is 2 into 2, which is 4, right? So it is 4D phase space, or we can write it 4D flow as well. So the answer for this question will be answer number 3. So how we calculated this one? So for this case, we just calculated the degree of freedom or generalized number of generalized coordinates for this system where the particle is constant to move on the surface of a sphere, and the degrees of freedom is nothing but 2, theta and phi. So we can see that the dimension of the phase space will be 2 into 2, which is 4. So 4D phase space, or we can tell that 4D flow. So these two questions were basically based on the number of degrees of freedom of the phase space, right? So now, okay, fine. Now coming to the third question. Yeah. So question number 3 is a point in phase space describes the temperature of the particle, reveals the real trajectory of the particle, describes the evolution of the particle, represents the instantaneous state of motion of a particle, and provides information about the force acting on the particle. So basically they are asking that what the phase space tells us. What they are telling me? That they basically, okay, I just want to write here one thing. Point in phase space, it basically tells us the specification of all the generalized coordinates and their corresponding momenta at an instant of time. That is very important, at an instant of time. So it is like full instantaneous state. Okay, so that means it gives the instantaneous state of motion of the particle, right? So the phase space basically represents the instantaneous state of motion of a particle. I just want to mention here one thing. It does not give the full trajectory. Oh, sorry. It does not give the full trajectory by itself. Okay. It does not. So that means the answer of this question will be a point in phase space is nothing but it represents the instantaneous state of motion of a particle. So always remember that whenever we are talking a particle and we are talking a point in phase space, let's say qi and qi dot. So this point is nothing but at instant time t equals to t, what is the motion of the particle. Now at t equals to t prime, the point is here. So that means at t equals to t prime, what is the motion of the particle? That is given by the q and q dot, which is phase space diagram. So phase space basically represents the instantaneous state of motion of a particle, not the full trajectory. It depends on the temperature, time itself. Now coming to question number 4. In phase space, a trajectory corresponding to a conservative system, always spirals inward, spirals outward, remains confined to a constant energy surface, collapses to a fixed point, becomes unbounded. Okay. So for this question, I just want to mention here, for a conservative system, energy is always constant, right? That's why it is known as conservative system. So the phase space trajectory is basically lies on the constant of energy surface. So I can say that the phase space for a conservative system lies on the constant of energy surface. Okay, and information I can tell is that this type of system allows, follow Hamiltonian dynamics. This just additional information. So basically, the conservative system should have the phase space which remains confined to a constant energy surface. This is the correct answer, because for the conservative system the energy is constant. That is the constant on this conservative system. Okay. Now coming to the fifth question. At a fixed point, a particle always has. Okay. So what is the definition of fixed point? So fixed point on a phase space is denoted by qy star dot in such a way that at qy star dot qy double dot qy triple dot all will be 0. So that means if I talk about, let's say, Q star as fixed point generalized coordinate, then Q dot, which we can say that generalized velocity, that will give me 0 value. And also I should have Q double dot generalized acceleration, that will also give me 0. So at fixed point Qi, all the higher time derivative will vanish. That is the main point for this fixed point. So like for Q as fixed point, we will have generalized velocity, which is Q dot is equals to 0, generalized acceleration, which is Q double dot, that is also 0. So fixed point has 0 velocity, 0 acceleration. Actually we should, by specific, we should tell that 0 generalized velocity and 0 generalized acceleration. Okay. So now we can see that this is 0 velocity and 0 acceleration. Okay. Yeah. Okay. Now coming to the next question. Question number 6. At an equilibrium point of a dynamical system, the particle always has what? Okay. At equilibrium point, the net force on the particle is 0. Yes? Okay, fine. So F total in going to act in such a way that it will give me the 0 value. And we know that F is somehow related with M into A, which is again M into F, or which is again M A Q dot double dot, right? Where Q double dot is acceleration. So for equilibrium, we will have 0 acceleration, because the innate force of acting on the particle is 0, right? So at an equilibrium, the dynamical of a dynamical system, the particle always has 0 acceleration. Okay, fine. Now maybe we can come to the next question. Yes, so in an autonomous system, a phase-space trajectory can intersect itself if, what is the condition for intersecting the phase space trajectory in an autonomous system. Okay. For an autonomous system, uniqueness of solutions prevents two different trajectories from passing through the same phase point at different times. This means that if a trajectory intersect itself, it must be a periodic or closed orbit. Once the state revisits the same point, the solution repeats. So what does this mean basically? It means that for the autonomous system there is a uniqueness of solutions, right? So uniqueness of solution basically prevent us to different trajectories from passing through the same phase point at different times. So at different times from a same phase point, if the two different solution is going through, that means there is a two different solutions at that point. But it is not possible for the autonomous system. So for the autonomous system, in principle, the the phase space should not intersect with each other. If a trajectory intersects itself, it must be a periodic, that means the closed orbit. Once the state revisits the same point, the solution basically repeats. So by pictorially, I can see that this is the case. If this is the case as a closed phase space, then at any time, at any position, the phase space is going to return at the same point. There, in that sense, it can be said that the phase space is going to intersect with each other, but it is intersecting in such a way that the solution is again coming to the same point after some time. So it's just like a periodic function and periodic nature of this phase space, and that will be only possible if the phase space trajectory is closed. So the motion has no fixed point. The trajectory is closed. Yes, that is true. In an autonomous system, a phase space trajectory can intersect itself if the trajectory is closed. Otherwise, the phase space trajectory will not be intersect with each other. Because if it will intersect with each other, then it will show a different solution at a single point at different time, and that is not possible for autonomous system because it is giving a uniqueness solution. Okay. Now coming to the next question. In an autonomous Hamiltonian system, trajectories in phase space is what? Yeah, this is the extension of this previous question. So in the autonomous Hamiltonian system, how the trajectory in phase space behaves. Okay. In an autonomous Hamiltonian systems, linear autonomous Hamiltonian system, the uniqueness solution basically implies that phase space trajectories cannot cross each other, which again means two different solution cannot pass through the same point. That I already mentioned, that this is the main point for the autonomous Hamiltonian system. The trajectory should not cross to each other, and if it is crossing each other, then that will be obviously a closed system. So that means it can never cross each other. Okay. Now coming to the 9th question. In a two-dimensional phase space motion, x dot, if a unit mass particle is acted upon by a force, the fixed points x dot star are. Okay. So fixed point is going to represent as x dot star. The evolution equation is like that: x dot equals to x and x double dot equals to, let's say, f by m. And f by m, and m is given as 1. So x double dot equals to simply f. And what is f? F is minus x plus x cube. X dot equals to x. X double dot equals to, no, actually it is not x dot equal to x. It should be, I have to write it like that. Let's say this is, I can write it x and v. So this will be simply v, and this will be again v. So x double dot equals to minus x plus x cube. Now at fixed point, we shows that x star, x dot star will be 0, x double dot star will be 0, x triple dot star will be 0, and so on. So what does this mean? This means that x dot is 0, very good, and x double dot, which is f by m, and in this case simply f, which is minus x plus x cube, that will also be 0. So for fixed point, minus x plus x cube equals to 0. From there I can see that x into minus 1 plus x square equals to 0. So x equals to 0 and minus 1 plus x square equals to 0, which gives me x square equals to 1, x equals to plus minus 1. So we can have the set of fixed points as x star, x dot star means 0 0, then 1 0, minus 1 0. So these three sets will give me the fixed point set. Okay. So now coming to the option. So what I told is 0 0. Okay, so basically 0 0, 1 0 and minus 1 0. So the second option is correct one. So how to calculate the fixed point? So for the fixed point, we know the condition that the x dot, x double dot, x triple dot all will be 0. Yes. So x dot will be 0. Very good. Now coming to x double dot, x triple dot. X double dot means it is nothing but f by m, and if in the question m is 1, so f is minus x plus x is cube, so that will give me the 0 answer. So for that, from there, if I just solve that equation, I will get x equals to 0 and x equals to 1 and minus 1. So as a whole, my fixed point will be x equals to, x star, x dot is 0 0, 1 0, minus 1 0. Okay. Now coming to the next question. Yes. For the system x double dot plus x minus x cube equals to 0. The fixed points in x dot phase space are. Okay. Right? So for that case, x dot should be 0, x double dot should be 0 and other things. So if I see the equation x double dot plus x, now I can definitely write it this. So at fixed point, right? So we can have this, this, right? Now coming to the option. Yeah, so the first option is correct. 0 0, plus 1 0, minus 1 0. Okay. Now coming to the next question. Yes. The Lagrangian of a particle is x equals to x dot square plus x to the power 4 by 4. One possible phase space trajectory can be what? Okay. So the Lagrangian is given and we need to calculate what will be the possible phase space trajectory. And phase space trajectory means like in the x and x dot plane, what will be the equation of motion. Okay, now coming to the Lagrangian here. The Lagrangian is x dot square by 2 plus x to the power 4 by 4. First of all, we need to check the EL equation, Euler Lagrangian equation. This is nothing but ddt of del L del x dot minus del L del x equals to 0. Now del L del x dot is simply x dot. Del L del x is x cube. So it will be like x double dot minus x cube equals to 0. So x double dot equals to x cube. Now I can write it x dA v dv dx equals to x cube, which will give me v dv equals to x cube dx. v dv minus x cube dx equals to 0. That can be written as v square by 2 x to the power 4 by 4 is 0. So we can see that v square by 2 x to the power 4 by 4 is giving me a constant value. And that constant, maybe I can write it like, let's say E. So x dot square by 2e minus x to the power 4 by 4e is equals to 1. So that will come up with 1 plus x to the power 4 by 4e. That is giving me the equation of phase space. Right? So maybe we can go for the option. Yes, I can see this is the correct option. So for that case, what we have done, we just calculated the L and then we just find out the Euler Lagrangian equation. Then from there, by some mathematical calculation, we are doing the phase space equation. Sorry. And then we are come up with x dot square by 2e equals to 1 plus x to the power 4 by 4e. Okay. Now coming to question number 12. The particle has Lagrangian x dot square minus x square by 2. The corresponding phase space trajectories are. Okay. Now they are asking not the phase space trajectory equation, but phase space trajectory behavior. But similar thing we will do. So basically L we are going to write here. X dot square by 2 minus x square by 2. Now Euler Lagrangian equation. Told me ddt of del L del x dot minus del L del x equals to 0. Right? So because it is minus 6, right? So we can write it some constant. Let's say I'm talking about it as E. So it is this is the equation of ellipses, right? So this will be the second option, ellipse. The particle has the Lagrangian L, x dot square by 2 minus x square by 2. The corresponding phase space trajectory is coming out as ellipse. Why? Because we can see that the equation of motion is coming out like phase space trajectory motion. The equation is x dot square by 2e plus x square by 2e equals to 1, and in the plane of x and x dot, this equation is nothing but the equation for ellipse. But the x-axis will be x and y-axis will be x dot. Okay. Now coming to question number 13. For the system described by x dot equals to x into 3 minus x minus 2y, y dot is y into 5 minus x minus y, the fixed points x, y are. Let me first write the given conditions. These two equations are given, and this should be fine. And they told us that fixed point is in the basis of xy. So can I write it like that? I mean, previously we were talking about fixed point as, let's say, q dot. So I can write as x as equivalent to q and y as equivalent to q dot. Okay. So at fixed point, we know that q dot, q double dot, dot equals to 0. So what does this means? If it is xy combination, then I can say that x dot will be 0, x double dot will be 0, and x dot is nothing but y, so y dot will be 0. You can see this. So we can say that x dot equals to 0, y dot equals to 0. Now what are the x dot, y dot? X dot was x into 3 minus x minus 2y, and y dot is y into 5 minus x minus y. So these two should be simultaneously equals to 0. So I need to find out the solution where 3 minus x minus 2y equals to 0, as well as y into 5 minus x minus y equals to 0. So what are the solution for this case? First solution, I can see that 0, 0. Because if you just put here x equals to 0, then total equation will vanish. Here y equals to 0, then total equation will vanish. But in the option, there is no 0, 0 option. So we need to check which one is correct. Let's say I am talking about 0, 5. That means x equals to 0, y equals to 5. Okay. So we told that these equations should be satisfied. This equation should also be satisfied, right? So let's say if x equals to 0, then this first equation is going out, no problem. But if I put that one to second equation, then what will be the answer? 5 minus 0 minus y equals to 0. So you can see 5 minus y equals to 0. So if either y equals to 0 or y equals to 5, and itself it is showing that y equals to 5, that is fine. So my first option is correct. What about 11522302? Okay. Let me check 1 1. What are the equations? X 3 minus x minus 2y, 5 minus x minus y. So x, y, in the next option it is showing that 1 1. Let me write here x equals to 1. So you can see that as x equals to 1, that means this whole should be 0 by any chance. So 3 minus 1 minus 2y should be 0. So 2 minus 2y should be 0. So y is 1. Okay. This y is coming as 1, but it should also follow this expression as well. So is it following? If I am putting y equals to 1, then 5 minus 1 minus 1, it should be 0. But 5 minus 2, this is 3, which is not equals to 0. So 1 1 is not correct. Okay. Now coming to next option. Next option is what? 5 2. Okay. X equals to 5, y equals to 2. X 3 minus x minus 2y equals to 0. Now you can see x equals to 5 means this is not going to 0, but that should be 0. So 3 minus 5 minus 2y equals to 0, which will give me minus 2 minus 2y equals to 0. So y is minus 1. That is not coming as 2. So 5 2 combination is also not correct. Now coming to the second one, 2 3 combination. X equals to 2, y equals to 3. So you can see that this was the case. Now x equals to 2 means I have to write here 3 minus 2 minus 2y equals to 0. So 1 minus 2y equals to 0, y should be half. That is not the case. Now coming to the last option, 0 2. That means x equals to 0, y equals to 2. Now see. If x equals to 0, that means 3 minus x minus 2y, 0 or non-zero, that does not mean bother because first one is 0. Now coming to second one, y into 5 minus 0 minus y equals to 0. So y into 5 minus y equals to 0. So the option is y is 0 or y is 5. But it is showing that y is 2. So that means it is also not correct. So we have already mentioned that the first option is correct. Okay. Now coming to 14. For the system defined by x dot is x into 2 minus y dot y into x minus 3. The fixed points are okay, similar to the previous question. X dot is x minus x into 2 minus y dot is y into x minus 3. At fixed point xy combination, our x dot should be 0, x double dot, which is y dot, that is also 0. So I have to write x into 2 minus y equals to 0, y into x minus 3 equals to 0. Now we can see that x equals to 0, y equals to 0. This condition is satisfied both. Okay. But in that option, not only 0, 0 is there, any other options are there, like 2, 3. Let me check 2, 3 is correct or not. Now see, x 2 minus y equals to 0, x is 2. That means this one should be 0. So 2 minus y equals to 0, so y should be 2. But it is showing that y equals to 3. That means 2, 3 combination is correct, not correct. So the first one is not correct. Now 0, 3, 2, 0. Okay. X into 2 minus y equals to 0. Y into x minus 3 equals to 0. So what is the condition? 0, 3, 2, 0. Okay. Let me write here 0, 3. Is this the correct one? If it is 0, then we are not bother about these things. Now coming here. If x equals to 0, then y into minus 3 equals to 0. So y should be 0. So this is also not correct. If this one is not correct, then we are not going to see this option. 2, 3 only. 2, 3 we have already seen that is not correct. 0, 0, 3, 2. Okay, fine. 0, 0 is fine, but 3, 2. Is it satisfying or not? If I am talking x equals to 3, then x into 2 minus y equals to 0. 3 into 2 minus y equals to 0. So y should be 2. Yes, y is 2. Fine. Now coming here. I'm sorry. If y is 2, that means 2 into x minus 3 should be 0. And x should be 3. And yes, x is 3. So xy, which is 3, 2, that is correct. So we can conclude that 0, 0 and 3, 2, these two are the fixed points. Now coming here 3, 3 only. Let me quickly check here 3, 3. So x into 2 minus y equals to 0, y into x minus 3 equals to 0. So let's say x is 3, so it should be 0, so y should be 2. So this is not correct. Okay. So for this question, what we have done, we just calculated x dot equals to 0, y dot equals to 0, and both should be simultaneously followed. So which option are going to follow simultaneously these two equations? And we have seen that 0, 0 and 3, 2 points simultaneously follow these two equations. Now coming to the 15th question. What is the phase space trajectory near the fixed point for x dot equals to x, y dot equals to minus y? Okay. So equals to x, y dot equals to minus y. Yes? Okay. So simply I can write here x dot y dot x y. So I can write here 1, 0, 0, minus 1. Okay. So we can see that lambda 1 is 1, lambda 2 is minus 1. How many information we can get from there? Lambda 1 is 1, lambda 2 is minus 1. So we can see that they are different in sign, which told me that no node is present. And also we can see that lambda 1, lambda 2. So lambda 1, lambda 2 is different in sign. So which told me that there is no node. And also we can see that lambda 1, lambda 2, at least one has positive ion value. So that means it is saying that unstable fixed point. Sorry. But these things we are not talking here in this question. What we are going to see that what is the trajectory for this case. Okay. So the equation again is x dot equals to x, y dot equals to minus y. So x dot by y dot is dx dy is x by minus y. So minus x by y. Right? So we can see that it is dx by x equals to minus dy by y. So after integrating, it will come as ln x equals to minus ln y plus ln c, which will be again ln c by y. So I can write is x equals to c by y, which is xy equals to constant, and this equation is nothing but a solution for rectangular hyperbola. So xy equals to constant is giving me the solution for rectangular hyperbola. So this one is correct. Okay. Okay. Now coming to the next question. Phase space trajectory near the fixed point of the system x dot equals to a, y dot equals to minus x is. So x dot equals to y dot equals to minus x. So for this case, what we need to do? X dot equals to y dot equals to minus x. So x double dot is y dot and y dot is minus x. So x double dot equals to minus x. So x double dot plus x equals to 0. So we can see that v dv dx plus x is 0. So v dv plus x dx equals to 0. So d of v square by 2 plus x square by 2 equals to 0. This will give us v square by 2 plus x square by 2 equals to constant. So x dot square by 2 plus x square by 2 is, let's say, e, and this is nothing but x dot square by 2e plus x square by 2e equals to 1. This equation is ellipse. So the option is the correct one is ellipse, right? Okay. Now coming to the next question. Which of the following systems have nodes as their fixed points? Yes, that will be a little bit lengthy question. Which of the following systems have nodes as their fixed points? So I just want to make here one notation information that for node, what is the condition? The condition is eigenvalue should be real lambda 1, lambda 2 should have same sign, not necessarily same value. Okay. So these two conditions should be satisfied for node. Eigenvalues should be real and eigenvalues should have the same sign. Okay. So based on these two conditions, we need to check these equations. First equation is x dot equals to x, y dot equals to y. So if we will write x dot y dot x y, then it will be like 1 0 0 1. So lambda 1 is 1, lambda 2 is 1. You can see that both are having same sign and real as well. So node is present, and what type of node will be there? That will be unstable, because lambda 1 lambda 2 both are positive. So any one is positive, that means it is a unstable node is there. But they are not talking about unstable or stable condition. They are just asking that which one will give the node. So this one will give the node. First one is giving me the node. Okay. Now coming that x dot equals to y, y dot equals to x. Okay. X dot equals to y, y dot equals to x. For this case, this will be simply 1 1 0. So we will have lambda 1 plus lambda 2 equals to 0, lambda 1 lambda 2 equals to minus 1. Now we can see that lambda 1 equals to minus lambda 2. So as we have seen that lambda 1 and lambda 2 should have the same sign, so there is no node. We don't need to calculate all the things, as we have already seen that lambda 1 equals to minus lambda 2, so obviously there will be no node. Okay, the second one does not have any node. Now the third one. Third one is x dot equals to x, y dot equals to minus 2y. So here x dot, y dot. One 0 0 minus 2. Here we can see that lambda 1 is 1, lambda 2 is minus 2. Different sign. So no node. Okay. Now coming to the next option. Next option is x dot equals to x plus y, y dot equals to minus x. So this will be x dot equals to x plus 1 y. That means here 1, here 1. There it will be minus 1, there it will be 0. Now we can see that for 1, 1, minus 1, 0. What will be the lambda? This will be 1 minus lambda plus 1 equals to 0. So it is giving me minus lambda plus lambda square plus 1 equals to 0. Lambda square minus lambda plus 1 equals to 0. So lambda is half plus minus root 3i by 2. Now you can see that these lambda both are complex. This is not real, so it will not give me the node. Okay, now coming to the next one. X dot equals to minus x, y dot equals to minus 3y. So for this case, x dot, y dot. This is minus 1, 0, 0, minus 3. So here lambda 1 equals to minus 1, lambda 2 equals to minus 3. Both are real as well as same sign. So it will give me note. So the fifth option is correct. So the first one and the fifth one both will give me note. Okay. Yeah. So now coming to the 18th question. Which of the following dynamical system exhibit saddle points? Okay, so what are the saddle points? Conditions. Lambda 1, lambda 2, eigenvalues should be real and different in shine. These two conditions are there for saddle point. Okay. Now coming to the first option. X dot equals to x, y dot equals to minus y. So again we will write here 1, 0, 0, minus 1. So lambda 1 is 1, lambda 2 is minus 1. Both are real, different in sign. So has saddle point. Okay, now coming to option number 2, x dot equals to x, y dot equals to y. So this is one, 0, 0, 1. So we can see that lambda 1 is 1, lambda 2 is 1. So for this case, real but same in shine. So no saddle point, because for saddle point different should be there. Okay, now coming to third option. Third option is x dot equals to minus x, y dot equals to minus y. So this is like minus 1, 0, 0, minus 1. Lambda 1 minus 1, lambda 2 minus 1. So again real but same in sign. No saddle point. Now coming to fourth option. Okay, fourth option is x dot equals to y, y dot equals to minus 6. X dot equals to y, y dot equals to minus 6. So x dot y dot x y, this will be 0, 1, minus 1, 0. So for this case, it is like lambda 1 plus lambda 2 equals to 0, lambda 1, lambda 2, 1. So lambda 1 is minus lambda 2 and lambda minus lambda 1 square equals to 1. So lambda 1 is plus minus I, lambda 2 is minus plus I. But the problem is lambda 1, lambda 2 both are complex. No saddle point because lambda 1, lambda 2 should be real. Now coming to the fifth option was x dot is x, y dot is minus y. So it is x dot y dot xy 1 0 0 minus 1. Lambda 1 is 1, lambda 2 is minus 1. Right? Okay, no, like this one has already done, right? So the fifth one is this one, sorry. X dot equals to 0, y dot equals to 0. So x dot, y dot, this would be 0 0 0 0. There is also no saddle point. So the option is correct only for first one. Okay. Now coming to the next question. Question number 19. For a particle of unit mass in the potential ux, how many stable and unstable fixed points are there? Okay, very good. So stable and unstable, that will be the case for the real lambda values, okay? I mean real x values, x and y, I mean x values, okay? So, yeah, let me write here. If there is any imaginary or complex solution, these will not give fixed point, either stable or unstable. Okay. Now coming to the u is x square by 2 minus x to the power 4 by 4 plus x to the power 6 by 6. So if I do f is minus du dx. So it will be x minus x is cube plus x to the power 5. Okay, fine. So at fixed point, let's say I am writing here x double dot will be 0 and x dot will also be 0. So x double dot means f, that will be 0. So that means minus of x minus x is cube plus x to the power 5 is 0. So if it is the case, then x will be 0 or 1 minus x sorry 1 minus x square plus x to the power 4 should be 0. But if you just solve this 1 minus x square plus x to the power 4 equals to 0, that will give me complex solution. So the solution coming from these equations are not giving me the fixed point. Now only x equals to 0 will give me fixed point. So only one fixed point is there. But now the question comes that which one is the fixed, I mean which type of fixed point it is, whether it is stable or unstable. Okay. So to check whether fixed point is stable or unstable, we need to do d2u dx2. If d2u dx2 greater than 0 at x equals to x0, then x0 is a minimum, thus stable point. Now if d2u dx2 less than 0, x is maximum, so it is giving unstable point. Okay, so for this question we saw that x equals to 0 is giving me the fixed point. Okay, but what is the nature of this fixed point? So we calculated du dx, which was x minus x cube plus x to the power 5. Now d2u dx2 1 minus 3x square plus 4x to the power 4. So at x equals to 0, d2u dx2 is giving me 0, not 0, 1, which is greater than 0. So greater than 0 means it is giving me the stable fixed point. As I mentioned that d2u dx2 greater than 0 means it is giving the stable point. So now coming to the option, one stable point and one unstable fixed point. No, this is not correct. One fixed point, two unstable point. No, only one fixed point which is stable. Yes, that is correct. No fixed points, that is also not correct. Two stable fixed point, one unstable fixed point is also not correct. Okay. Now coming to the last question. For a unit mass particle in the potential u equals to x square by 2 minus x cube by 3, the number of stable and unstable fixed points is, okay, ux is x square by 2 minus x cube by 3. Very good. So f is minus du dx, which is x minus x square. So at fixed point x dot equals to 0, x double dot equals to 0, which is f. So x minus x square is 0, x equals to 0, 1 minus x equals to 0, x equals to 1. So I can have two fixed points. X equals to 0, x equals to 1. Now what is the nature? To have the nature, what I need to do? d2u dx2. So ddx of x minus x square, which is 1 minus 2x. Okay. At x equals to 0, d2u dx2 is 1, which is greater than 0. That means x is minimum. So stable fixed point. Now at x equals to 1, d2u dx2 is 1 minus 2x, that means 1 minus 2, which is minus 1, which is less than 0. That is giving me x is maximum. So x equals to 1 is unstable fixed point. So we can conclude that x equals to 0 is giving stable fixed point, x equals to 1 giving me unstable fixed point. So option is yes. So one stable, one unstable. One stable only is wrong, one unstable only wrong, two stable, one unstable wrong, none. That is also wrong. Okay, so maybe I can just go through the questions again. Yeah. So this is basically talking about the phase space trajectories. This question is 2, answer is 2. Okay, before going to the questions again, I just want to mention here one thing, that final exam of classical mechanics of a single particle, that will be computer based exam, MCQ, MSQ, numerical, 3 types can be there. A high weightage of questions can come influenced by assignment questions this year and previous years. Okay, so your question will be computer based, and MCQ, MSQ and a numerical can be there. These 3 types can be there. High weightage of question can come influenced by assignment questions. Basically whatever the assignment you have already done till now, and as well as in the week 12 also. So this year and the previous year questions what I was explaining. So based on these questions, a high amount of question will come in the final exam. Okay, and admit card will be provided soon, maybe like 1 week before the exam or something like that. Okay, so these things I just wanted to make. Now I will just go through the questions again. This is the first question. Which has the answer 2. This is the second question. 4. This is the third question. Represents the instantaneous state of motion of a particle. This is the next question. Remains confined to a constant energy surface. Then this is 0 velocity and 0 acceleration. This is 0 acceleration. The trajectory is closed. It has that they can never cross each other. It has the fixed point as 0, 0, 1, 0 and minus 1, 0. This has like 0, 0 and plus minus 1, 0. It is like x dot square by 2e equals to 1 plus x to the power 4 by 4e. It is ellipsis. This has the answer 05. This is 0032. I have checked each and every options in detail so that it should not have any confusion. This is rectangular hyperbola. This is ellipse. This has two options, x dot equals to x, y dot equals to y, x dot equals to minus x, y dot equals to minus 3y. X dot equals to x, y dot equals to minus y. This is the option. I should not write this. I should remove this portion because this has already been explained in the very first option. Yes. Then only one fixed point which is stable. This is one stable and one unstable. These two last two pages were basically denoted by for the exams. Okay, so this is for today, and we will meet on the next class, and that will be the last class. I am not going to take any extra classes for this course, and that will be the week 12 previous year assignment questions with discussions. So okay, tata, bye bye, good night. And if you have any question, you can just put that question to the discussion forum so that we can answer together. And obviously don't worry, this PPT will be uploaded in the Google Drive, and this video will also be uploaded in YouTube. Okay.